Hey everybody, how are we doing today? I have a special guest on with us today. He's an author, and his name is Mark. He wrote a book called Masters of Reality, Super Relativity, and Unified Field Theory. And I want to make sure I get the pronunciation of his last name correct. I'm going to bring him in here. Let's see. Can you hear me, Mark? Let's see if I can get you added.
Closer to the microphone, maybe. Try that.
There we are.
Yeah.
Sorry about that. All right. So, I want to make sure I'm getting the pronunciation right. Is it Flori? Is it Florino? Fiorentino? Fiorentino.
There you go. Perfect.
Okay. I want to make sure I get the pronunciation right. I hate butchering names. But how you doing today, Mark?
Very well, thank you. How you doing?
Oh, not too bad. Can't complain. So we have quite a bit we can talk about with this book that you have here. And why don't we just start with, maybe you can give the people a little bit of background on yourself and what eventually led to you writing this book, maybe.
Sure. It's an interesting story that spans about 45 years. Generally, I didn't expect that I would write a book until I was kind of guided toward it over the years in one way or another. I got into science and physics and really metaphysics, which is the study of the nature of things, since back when I was around 10 years old. I had an introduction to science in an odd sort of way. I was going to school catechism. I was a Catholic, and the nuns at the school wanted to have us children all go and find a saint born on their birthday. And so I went home and I asked my parents. They didn't know of any saints. Finally I looked on the calendar in the kitchen. I saw Albert Einstein's name was on my birthday. So I went to the Encyclopedia Britannica, read about Albert Einstein. Eventually I read about the unified field theory, also in the Encyclopedia Britannica, and fell in love with that idea of concept. So the rest of my life, just kind of letting my mind run in the background, anything any TV show, science show that I saw, any UFO book that I read, I was always looking for clues to the unified field theory, the one that Einstein came up with back in the 30s and the 40s, the one that he worked on. Is it basically a field theory? Which says there's something out there that must be continuous. Quasi-elastic solid is what they eventually assumed was the fundamental field. And that's how I got into it, just kind of a passing, interest as a child that grew substantially over the years until, that's my main thing that I was working on and reading, basically anything I can get my hands on. I'd like to read up to modern day, all quantum mechanics stuff. Although I agreed with Einstein that quantum mechanics was incomplete, and eventually I was convinced that there was no way that quantum mechanics was ever going to lead to a theory of everything. Because I believe Einstein was right in his arguments. Unfortunately, he lost the debate with Niels Bohr, and that was forwarded in advance in the quantum mechanics theory, which really doesn't make sense. And Einstein tried multiple times to point that out, and eventually science went the wrong way, in my opinion. And I stayed the path that Einstein laid out. Einstein and Maxwell, and Faraday, and Newton, and Lorentz. These guys that had it right, and each one pushed the ball forward to the point where Einstein took over and was really 90 some odd percent there, and that's where I picked up and continued carrying the ball over the goal line and solved the problem. And the solution is in my book and in the paper that I'm writing now. I'm going to upload eventually to a journal. So that's how I got into it. Along the way, of course, I worked at high-tech companies like IBM and Microsoft. So I was always involved with electronics and computers. I studied electronics, went to tech school here in Florida. It was a very happy experience for me. I got a skill in the up and coming field of electronics, which led to computer electronics, something I really loved and enjoyed in my working years.
Well, you were talking about the idea of the theory of everything, understanding everything. Do you ever think we're going to come to a better understanding of quantum physics and being able to explain it to people?
Uh, well,
because I feel like it's one of the hardest topics to wrap our heads around.
Yeah, quantum mechanics is a useful utility tool if you want to predict things like, if I smack these particles together, what other kinds of particles can I get? The mathematics is really good. It's based, of course, entirely in probabilities. And probabilities can't tell you, if you have a mathematics based in probabilities, it can't not tell you how things actually work. You're never really going to get mechanical explanations. So even the word quantum mechanics is kind of flawed. They should call it just simply quantum probabilities.
Yeah.
Because there's what mechanics is involved is been strapped into the equations, differential equations that might be used with it. Something like Schrodinger's equation certainly was a major breakthrough for quantum mechanics, but
Schrodinger and the slit experiment, and where they were shooting at the slit, and the atoms and the particles were splitting, and then sometimes they'd even get multiples, or it would miss a spot when they had a hole in the field that they were shooting it at.
You're talking about the double slit experiment?
Yeah, the slit experiment.
Yeah, Feynman said that was a classic example of how quantum mechanics works, and he always thought it was great evidence in favor of quantum mechanics. But that phenomena can be absolutely and perfectly explained using classical wave mechanics, and physicists know this. They just choose to accept the many different interpretations for explaining the double slit experiment. And there are many, and that's a flaw in itself. If you don't have one single explanation for your mathematics, odds are it's not right. Certainly, all of them can't be right. Particles go in all different paths until we look at them and the particles decide which path they're going to choose and take. If you're buying into that, you're buying into something that's never really going to be correct and proven correct, because particles don't decide. It's the way things really work is purely classical. It's deterministic. It's cause and effect. And what we do with these experiments that become very tricky is we're looking at things, and the only way we can look at things is if we bounce off something off of the particle or force that particle to interact. As soon as we do that, we affect the experiment and the outcome. And so really, will quantum mechanics ever be the thing that leads to a theory of everything? No, because it can't explain how things work. And it certainly has failed miserably in explaining gravity. And it's not really, as my theory, the theory of super relativity states, everything is really all about a particle to space interaction and a space to particle interaction. That's where you get force, action at a distance. The primary forces of nature are not quantum based. Magnetism, the electrostatic field, and gravity are all bendings of space, specific types of bendings in a continuous space. And of course, we use particles to generate these fields and so forth. And I go into that entire explanation in my book. But ultimately, there's three primary fields, and these force fields are in a continuous space. And that's why a theory, a classical field theory is the way to go to solve these problems, because particles are made of this continuous space. They are consubstantial with it. So even the particles that are the carriers of the in small quantities of the electrostatic force and the magnetic force, and eventually I proved even the gravitational force, are based in field theory and not in quantum mechanical theory.
I've always liked Neil deGrasse Tyson's layman's explanation for it. It's like when you drop something in the seat of your car, and then when you reach for it, it goes farther down, and it's even more out of your reach. And that to me has always been a good way of describing quantum physics and quantum mechanics.
Yeah, it's true, because there's never a good, solid, sensible explanation for how things work when you're basing your model in probabilities. There's nothing to really grab onto. Like when I use my formulas that I use to predict masses and stuff, there's a mechanical model behind it using equations that are actually from Newton's time. And so what I model is not anything at all using probabilities. And Feynman said, if you're going to model reality, you better use quantum mechanics. Well, that was a bad statement, because in the end, it turned out that no, that's wrong. If you want to model reality, you need to use classical physics. He even began to weaken and wobble a little bit. Feynman did. He said at one time to Lee Smolin, he said, if all your colleagues have tried to demonstrate that something's true and failed, it might be because that thing is not true. And that's where you get into quantum theory. If that thing is not true, then all your efforts are going to be a waste. And this is another thing that Feynman said. He said, the extreme weakness of quantum gravitational effects now poses some philosophical problems. You better believe it. Maybe nature is trying to tell us something new here. Maybe we should not try to quantize gravity. And in quantum theory, they say that gravity is caused by an interaction with a particle known as the graviton, which they never found. And now they make excuses for why they can't find it, instead of just admitting it doesn't exist. Therefore, the standard model is wrong. If it doesn't exist, the standard model falls apart. It's already a kludge now, but this really presents a big problem. So there's that problem out there, like you said. You reach back and looking for something, and it's going further and further into the seat, or like I used to say, they've gone into a rabbit hole and they just keep going deeper and deeper in it. And as long as they're in that rabbit hole, they'll never find the truth. They'll just be coming up with these new senseless type of schemes to try to make some sense out of something that really is not physically true.
Yeah, it's a constant chase where basically the only thing that you ever see is where what you're looking for once was. You're never actually going to see where it's at. So it's
well, it becomes tricky because you have the observation effect. When we mess with these particles, they're easily affected. The instrumentation that we use, the particles interact with it, like the double slit experiment. The particle has a strong interaction with the entire double slit. Even though the particle does go through one hole or another, part of the particle winds up, according to my theory, going through the other hole. And so that whole substructure together, when it interacts with both holes, has an self-interference effect, which causes the interference pattern on the wall or the detector. Well, you don't get that interference pattern as soon as you cover up one of the holes, because now you've affected that geometry that the particle is interacting with. This is not really advanced deep science here. This is common sense science. And for some reason, they so desperately want quantum mechanics to be the explanation and the truth that they kind of ignore the simple facts of the situation and choose one interpretation um, that's wrong. I mean, what if quantum theory is wrong? I mean, that's what we're all worried about, right? This
Yeah.
is the soft underbelly of the whole project of quantum gravity. If quantum theory is wrong, then trying to combine it with gravity will have been a huge waste of time. That's from Lee Smolin. There's people out there that are, sniffing around, and they're highly suspicious of quantum mechanics as being the theory of everything in the unified field theory. It's the whole particle to particle interaction model is a level above the foundation, and we need to be at the foundation in order to understand the theory of everything and the unified field.
Well, I think that'll help us jump into this first question I had for you, Mark. And how does your theory help you with the discovery of the origin of mass itself?
Well, I followed Einstein's path, and it was a fascinating path. He had, which actually comes from special relativity. So, really, gravity, origin of mass, and inertia are really basically slightly different circumstances that are really the same thing. The circumstances change, so you get inertia, but once you get down below the circumstances and understand the central cause of mass, gravity, and inertia, you find that this is the cause. Right now, I'm going to say it. Fundamental unbalanced charges moving in an accelerated manner causes the gravitational field to emerge, or particles to have mass. Why is that so? The key word is acceleration. Einstein said in the theory of general relativity that somehow acceleration and gravity are the same thing. But he didn't know what the mechanical link is. What I did is I found the mechanical link. Whenever you get a particle, an unbalanced charge, fundamental like a quark, something of that nature, to move in a circular pattern, that's an accelerated pattern. Most people don't know that this type of motion is accelerated. Most people think about acceleration as, you put the pedal to the metal and you pull back in your chair and you feel that inertia, right? That inertial drag.
Yeah.
That's one type of acceleration that also causes the increase of mass. So acceleration causes the increase of mass. And now I'm going to link you to why acceleration causes the increase of mass. And this is from a passage from Amir D. Excel's book entitled God's Equation. And he gets it, or he would have never put this in his book. And Einstein got it. He actually got this idea I'm about to tell you. He actually gets it from Paul Ehrenfest, who does a mind experiment using the theory of special relativity. And Paul Ehrenfest, I believe, got it from Max Born. But when Einstein read it, he got excited, and he wrote like 8 or 9 more papers on this, what they call the Ehrenfest paradox. So let's look at Einstein's happiest thought, and this will explain how gravity works. Einstein followed the line of reasoning that began with his happiest thought of his life. Still at the Swiss Patent Office, he conducted one of his famous thought experiments. Einstein imagined a circle spinning in space. The center of the circle did not move, but its circumference was moving quickly in a circular direction. Einstein compared what happens in several reference frames, a standard tool he used in developing the special relativity theory. He concluded, using his special relativity, that the boundary of the disk contracted as it spun. Now we're at the core of reality. I notice the word I use, contracted as it spun. There was a force acting on the circle at the boundary, the centrifugal force, and its action was analogous to that of a gravitational force, but the same contraction that affected the outer circle left the diameter unchanged. Thus, Einstein concluded in a way that surprised even him, the ratio of the circle to the diameter is no longer pi. He deduced in the presence of a gravitational force or field, the geometry of space was non-Euclidean, which means space had a bend to it. So a Euclidean space is just a flat, you can picture grid marks and everything's just straight, right angles and everything. But when you bend space, it becomes non-Euclidean, and it has a certain bend. And this bending is a contraction of space. And that's the core, that's the origin of the gravitational field. So the gravitational field is really a gradient field, a contraction. So you have a particle like a neutron or a proton. That thing, Einstein was studying, but he didn't know about the quarks, and I did know about the quarks. He died about 10 years before they actually discovered the quarks. So he's looking for a geometry that would do what I just read in this article, this statement from God's equation. He knew that there was a dynamical geometry that was spinning fast that would create the phenomena of mass. But all they knew in his time was the neutron was just sitting there and the proton was just sitting there, and they didn't know there was anything really inside of them yet. And what I was able to determine is the pattern of motion looks like this. The three quarks form this thing called a trefoil knot. And this is what's going on inside of the proton and the neutron. And as you can see, it's a knot. So the strong force, which is mistakenly credited to gluons that are not there at lower power probes using electrons or photons or whatever, that don't disturb the inner core of the neutron and the proton, they don't see gluons. They don't see gluons until they smash the neutron and the proton, and all these things come flying out of it, and they deduce incorrectly that these things were hidden there somehow, and this revealed them with this collision. But no, the way that the particles work and generate their mass is through moving at 9/10 of the speed of light, 99% of the speed of light, and they generate this shape. And this shape, electromagnetic shape, is what holds the quarks together, not the gluons. There's no gluons there in an undisturbed neutron or proton. So that's and that structure I showed you is not only doing that rapidly, created by the rapid motion of quarks at 99.9% the speed of light, which I determined in a paper that I wrote some years before I wrote this book. And it was helpful for me to determine how mass is created now in the formulations that I use. That explanation that this structure, this dynamical structure, if Einstein knew about it, he would have solved it back in the late 50s, early 60s, if he had lived that long. But he didn't know about it. So he had to imagine what was going on inside of the neutron and proton, and he wasn't sure. But I was able to determine that. I actually got this thing. I call this the signature of God.
Okay.
So there's a whole story behind how I found this, and it's in my book. I mean, it's like 2 to 3 chapters, so it's a bit much to go into here. But there's a whole story how I found the signature of God, and I thought about finding the signature of God from Einstein. I was inspired to look in a way that normal physicists would not look, and that is to look to people. I decided I would go to the creator and ask the creator himself how it was done. You want to know how something works. It makes sense to go to that somebody and ask that creator, how does this work? That's what I did when I was troubleshooting at IBM and ImageSoft and companies I'd go to. If I knew the guy that wrote the program or created the piece of hardware, most cases I did, and there was a problem, I'd go to them and ask them, and I'd get a good, solid, sensible, correct explanation. So in this case, what inspired me to find the signature of God was something that Einstein said. And he said, I want to know how God created this world. I am not interested in this or that phenomena in the spectrum of this or that element. I want to know his thoughts. The rest are details. So thinking about that, I says, wow, could somebody read God's mind? And I know you can't read his mind. He's just got to communicate to you. You know, God is not accessible that way, only through communication. And I thought to myself, well, who has that kind of communication with God? People in near-death experiences have that communication. So I thought to myself, well, maybe if God wants us to know it, if we're ready to get that knowledge, I'll just start reading about NDEs. I'll go to the website and look. And I'll look for any NDE that talks about mass, talks about seeing a dynamical geometry, and I knew it would have three elements because there's three quarks inside of the proton and a neutron. So I knew it would have to be something that had a three, in this case, loops in it or whatever. And sure enough, I found the lady that saw that, and God telling her, I created this. I am the source of the sun. I am the energy that forms mass. And so I'm getting excited when I'm reading all this, and I'm saying, he sent the message. He sent it through this person. So I contacted her and tried to work with her group for a while. But unfortunately, her group, they're guided by a mathematician that's strongly in favor of quantum mechanics and does not believe in objective reality. So I couldn't really continue. They heard me out. They were very gracious. But we went our separate paths. But that's the information I needed. I got the information I needed. And I tried to convince them, hey, this is much more than what you're thinking it is. This is how mass in the universe is manifest. Without this system, this purely mechanical system of operation, we wouldn't have planets and stars, particles, elements, nothing. This all comes about through this process. So that's how I got to how mass is created, which basically is from the accelerated motion of unbalanced charges, which creates angular momentum, which is accelerated motion. And when that happens, in and around the particle as it's accelerating, there's a contraction of the physical space. And that is gravity. It's just really that simple.
Well, so when Einstein realized the gravity's effect on the whatever object is traveling, when he witnessed the effect on the object, how it contorted it, I think that was the word that you used.
Are you talking about special relativity now, and when things are accelerated to near the speed of light?
Well, yeah. Well, and that's I kind of wanted to talk about both of them. What I was wondering is, in your opinion, do you think the mode of future transportation, when we think about long distance travel, like off planet travel, do you think it's a matter of like end destination, start destination, and we need to use gravity to bring them closer, or are we going to think about a propulsion system to get you there without bending space time?
Yeah, I have the answer to this. Clearly, that first one you did where you bend space-time gravitationally, the amount of energy it would take to actually do that would be astronomical. I don't know of anyone, and I don't believe even aliens, advanced technologies, millions of years ahead of us, they don't do it that way. They use a magnetic propulsion system. And so what they do is option 2, what you suggest, just a faster way to get it. The key to getting through outer space is to move beyond the light speed barrier. And you don't bend space in a way to cause a gravitational effect, because that actually will slow you down. And that will create more inertia. Uh, it's a bad deal. And if you create enough gravitational, like a black hole level event, you're not going to survive that.
Yeah.
Ship isn't going to survive that. It's going to be crushed. You just can't use that method. It's not practical and it won't work. The way to do it is by using what I describe in my book as the slip wave, the slip wave spatial bias drive. And it uses magnetic propulsion, and that's clearly what the evidence shows out there from people who have examined UFO landing sites. And I've read books, and I remember reading some as a teenager where the U.S. Air Force was out there with what? A magnometer. What's a magnometer? It's this thing that measures
Oh, looks like Mark might have got disconnected. We'll get him back here connected, but I have some more questions here for him. We're just gonna wait for him to get connected. Yeah, Mark's got a lot of knowledge on this, and we're just going to get into now how, because he believes that there is a way that he can explain how UFOs work. I just get ready to ask you that here.
Okay, there we go. All right, so
I was just getting ready to lead into. I was thinking that was just going to lead into our next question, which was the explanation of how UFOs work, and talking about that magnetic field.
All right, so before the glitch, I was talking about magnetic fields, and they use magnetic fields, and I was talking about the evidence that I found in UFO books, which state clearly that magnetism has something very important to do with gravity and anti-gravity.
And you were also saying that's what they were using things to measure the magnetic fields at landing sites and stuff like that.
Magnometers, which are things that. So the Air Force already knows this back in the 50s. They already knew it, that they're going out there in the 50s and the 60s, and they're looking at UFO sites, and they're looking for magnetic field evidence. And there's so many reports where the cars die under the engines die, the radios are changing stations, or they hear this hum, and they got
the lights do weird things. Yeah, all the electronics seem to go haywire.
Yeah, which a magnetic field will do. And I used to play with magnets and radios, AM radios, when I was a kid, and I could tune the station by bringing a magnet closer or farther from the radio. I could actually enhance the reception by bringing the magnet closer to the coil that the AM radio uses as an antenna. There was so I was already playing around with electronics and familiar with that magnetism can strongly affect electronic circuits, and certainly the work of Michael Faraday backs that up big time. There's a big connection between magnetism and electrostatic current charges moving through wires and so forth. So there's loads of evidence that link magnetism to anti-gravity. And so I worked on it over the years. It was mysterious to me for many years. Why does magnetism create anti-gravity? And it's quite simple. It creates a force that's counter to the contraction of space. There's something about a magnetic field that has the opposite effect. It causes the space, the secondary effect, to expand. So what really is a magnetic field? We have to understand. So a magnetic field really only occurs when electrostatic charges, like electrons, move. When they move, since electrons are twists of space, basically, when they move through space and they're twisting, that space around reacts and rotates. So the magnetic field is a torsional reaction to moving charge. So that's explainable, that's accepted. Nobody argues with that. And we have 2/3 of the unified field theory solved right there and back in Maxwell's time with electromagnetic theory. So what went unnoticed is that magnetism causes space to stretch, to thin out. And this can be used to create a bubble of force. Whereas if you got a strong enough magnetic field, you can distort space in such a way. I apologize for that.
Oh no, it's okay.
And let me just shut this thing off. Okay.
So it almost creates like a bubble around you where the energy is so strong that nothing could penetrate that field.
Yeah, very similar to that. The force field, the magnetic field, as a byproduct, causes space, to rotate. This is a stretching of space. Imagine if you're playing with silly putty, and you put it down on a comic strip character or picture, lift it up, and you look at the picture. Now take the silly putty and twist it. Look what happens to the picture when you twist the silly putty, which is basically an elastic device. Sort of it stretches, and that's the same thing that happens in space. And you need to lower the density of space so that you could not only cancel gravity, but create a field, an area, a bubble within space that is possible to break the light speed barrier. Because Maxwell discovered that the speed of light is really determined by two properties of space. The oh god, the what are the properties? Permittivity and permeability. These are two properties of space, and when you reduce these, if you look at the equation, speed of light equals 1 over the square root of permittivity times permeability. Whenever you reduce them, you increase the speed of light number. So that's what they do when they create the metamaterials. They reduce that property within the material, which allows light or electrons or whatever to flow faster inside of that material once they reduce the properties of permittivity and permeability within that material. So it's already a proven fact that we can make things go faster, especially photons, if we do this. So what I'm saying is magnetic fields do this when they're really strong. They stretch, the level of space becomes dense, less dense, and so it actually expands. And so that's what you need, which is what I call the slip wave bubble. And you can use this technology. You can make a gradient field by putting a series of coils together. Let's say you had a spaceship that's in the shape of a cigar shape, a very common mothership shape that many people have seen over the past decades. This shape is very good for interstellar travel or even intergalaxy travel because you can put the coils in concentric rings from the beginning to the end of the spacecraft. So you turn on each coil, and each one after that you turn on with more energy until you got the one at the very end, which is the most intense magnetic field. So what you do is you create a gradient field of force from the beginning of the spaceship to the end of the spaceship. And this creates a pressure wave inside the field of the slip wave. And pressure gradient is what you need to cause particle motion, and it's what you can use to cause spaceships to move. So by discovering how particles move, by using the slip wave technology that they basically use, they have pressure gradients inside of them caused by the electrostatic field. And so they have motion, internal motion is caused, and eternal motion. It's never ending. It's perpetual because the structure within the ether field creates the motion field. So we're using that same type of technique to create, or the aliens have in this case, create spacecraft that not only have anti-gravity fields, but inertia is canceled inside of this field, and using the magnetic field, it's doing all this work for us, and it's providing propulsion. And how fast can you go? Well, the more you reduce permittivity and permeability, the faster you're able to go. So now, not only can you go at the speed of light, you can go 10 times faster. You can go 100 times faster. You can go 1,000, 10,000, 50, 100, a million times the speed of light. And that's what you need to get to other stars. Going at the speed of light, way too slow. Using rockets, forget it. It's never going to happen with that. You need to go really, really fast, and you need to do it in a way that is safe. If you build the ship right, it's safe. If you don't, it's incredibly dangerous and is lethal. So there's a lot of pitfalls that one must be aware of if you're going to use that type of technology, so that people get there in a timely manner. If you want to get to like Proxima Centauri, 4.2 light years away, the nearest star, you can do it in 20, 30 minutes. That's practical. That's the way to get around. You can't do it at light speed. It would take 4.2 years. It's intolerable. It won't work for civilization. People will die on board the ship waiting to get to just the nearest star. You want to get there like you're going to pick up milk at the grocery store, that kind of time period. And the only way to do that is to move really, really fast. So that's how I propose that we build our starships, and I'm pretty darn sure that's how the aliens use this technology, because just about everywhere we go, we know they're using a spatial bias drive, because we see no rockets being used, nothing coming out of these vessels.
No noise. Yeah.
Noise. Occasionally, we do hear a hum, which is a clue
Of a magnetic field.
Yeah, the magnetic field is causing a vibration in the hull of the ship, depending on what materials they use to um, make the ship. It might have a little hum to it, especially in the hover mode, which they can use an oscillating current of sorts to use it just to hover in the spot. You don't need to
Well, and
have
I think depending on if you're traveling in outer space or whether you're traveling around a planet, like I assume that you would use the planet's energy field as well, or magnetic field as well. And that's why I've always seen it to be interesting to see like the angles that the crafts are at when they're moving or when they're skipping. It's almost like they're at a downward angle, like they're perpetually falling and like moving along when they're on the planet itself, not space travel, but maybe using the Earth's magnetic field to travel around. If that's like a hover mode
that's way too weak. What I think is happening when you see these odd maneuvers, they're demonstrating that they have spatial bias drive, because you can use the field shape to configure the shape of your ship. And when we build a ship, we use, designs that, are using air current flows, and, we can't fly a jet like this, would crash.
Yeah, it's all aerodynamics. We're trying to
demonstrating that around the ship, the air is so rarefied by the magnetic field that you're in almost a vacuum state, because the air is being shuttled around by the magnetic field. And so that's why you don't hear a sonic boom, and they can make these maneuvers and not superheat. If you try to go, 10 or 15 times, Mach 10 or 15, you're going to have heating problems.
Oh yeah, well, and just the inertia on the body, just the inertia throwing your body around.
Change directions, and all of this is fixed using a magnetic spatial bias drive. All of that, you're basically floating inside of this craft when it's making these maneuvers. You feel nothing. You don't feel any change in shape or a change in direction at all. You're going with the bubble. Wherever the bubble goes, you go. And as long as you're inside of that spatial bias field, you feel like you're floating. Anti-gravity, no inertia, no dying from, your bones being crushed by, 100 Gs or whatever. If you're going, as these UFOs do, they go 10, 15, 20,000 miles per hour and then make a right turn. There's no human that's going to survive that turn. They're all going to die unless you have inertial shielding. And the only way to achieve that is using the magnetic spatial bias drive, or the slip wave spatial bias drive. It handles all of that. It's really a perfect design, and I credit the creator for designing the universe in a way that we could have this possibility. It's really important for life forms like us to be able to visit other planets, and you can't do it using rockets and this kind of old timey technology. It's, it's it's okay to go to the moon or something, but or just put satellites up in space, but it's no way to you can't even get to other planets in a reasonable amount of time. So you have to come up with a system that moves the spacecraft many times the speed of light.
Well, it's interesting. The second you described it, it reminded me of, I don't know if you've seen the newer version of H.G. Wells' The Time Machine movie. He's got this craft and these objects spin around him. It's circular and they create a field around him. It's almost like he is in a sphere that's traveling through time, but he's separated from the outside. I think at one point a necklace falls off of his neck and then falls outside of the field, and you like watch it age as it's like falling. It's so interesting to see. But that's what he had, is he had these metal rings that were spinning around him at a high velocity, and then eventually created a field around him.
Yeah, that kind of motion would create, and it's a known fact. You have to have a deep conversation with a physicist to get them to admit this, but a spinning disk or a spinning, disk, well, basically those are not cylinders, but rings, spinning rings, will get heavier and heavier as they approach the speed of light until they become so massive you would create a black hole. But, create something like that physically that would get to those speeds is impossible because nothing that we make is rigid enough to do that. They'll fly apart. Those rings will fly apart way before they generate a gravitational field that slows time, and in that case would actually stop time. And if you were to create a black hole using this technology, then you, in theory, could go back in time, but that is not a proper calculation.
But I was pulling up
really
a couple of pictures. But yeah,
basically
basically
the way to make a time machine. But even the older version had something spinning, as I recall. That's cool looking.
But yeah, but it's interesting that they stick with that idea of creating that field around them to separate, from trying to travel across the planet or.
Yeah, the way we do time travel, the way that I write about in my book, and the way I believe that the government has succeeded in doing is by building the Stargate. And basically what you have to do is accelerate particles like the photon beyond the speed of light. And you do that using the metamaterial. So you build a framework, and then you feed this framework with either light, more than likely light at a specific frequency, which then gets compressed, and so then is emitted from the framework or the center of the Stargate. You know how the Stargates look on this TV show. So emitting from that frame is a ultra high frequency photon electromagnetic wave that tunes the space to higher frequencies where other dimensions and other dimensions, physical dimensions, and perhaps even time dimensions are accessible by doing this. And the only way we can get forward and backwards in time, the only way a time machine can ever work, is that time itself is going, all of it, past, present, and future, is happening all at the same moment. And so what you have to do is like go from one room to another through a portal to get to a past time or a present time. And so that's the way that most likely I believe time machines are working. So there's no spinning thing going around there. There is high energy photons being emitted from a framework, and they may use ultrasonic sound to also help the air vibrate and so forth. What you want to do is make the space vibrate at such a frequency that it actually tunes to another realm, uh, dimensionally speaking, whether it be time or physical. And
So with that magnetic field, though, is that what you use to create an anti-gravity situation? Is having that field around you, or
a magnetic field, that's what creates anti-gravity, as I said before.
okay,
There's no doubt that in my mind, at this point, magnetism, and I'm going to hold back a little something for a presentation that I don't want to say it yet, but magnetic field in a certain configuration will generate the necessary field distortions to create anti-gravity and propulsion. And so all we have to do now is really get to work and prove that by doing certain experiments that I mentioned in the back of my book, Final Chapter, basically the call to action. The physicists, experimentalists put together these experiments and determine, quantify exactly how much magnetism it takes to weaken the gravitational field and how much it takes to cancel the gravitational field below, let's say, you make the magnetic field at a certain level, and then you measure something above, right above it, and you see it will become lighter and lighter the stronger the magnetic field is below that object, because you're basically shielding it from the gravitational field that's coming up from the Earth, and
okay,
and so you basically block it by replacing the contraction field with an expansion field. So the device that's hovering above or being held by a string or whatever simply becomes lighter and lighter until it's floating, weightless, above this field. And that's the kind of experiments I propose that are fairly simple and certainly can be done with the technologies we have now. All we got to know is how much magnetism, how many Teslas of field strength does it take to see these effects happening, and that then we'll know how much energy we need to make an anti-gravity field that'll actually make something float like a small spaceship or whatever. This is doable. This is doable science. We just got to stop with not believing in anti-gravity.
what type of energy would it take to produce these type of fields?
Well, that's why we need to do the experiments so that we can see, maybe it takes 100,000 kilowatts for, a power in a superconducting magnet, using the technique I will be describing through the anti-gravity group and so forth, to create a specific field strength. And you write these numbers down. You say, okay, at 10 Teslas, we had 5% decrease in the weight of the object above the field. And at 50 Teslas, we had 25% decrease in the mass or the weight of the object. And then you can build a formula and quantify exactly how much it is. I don't know yet. We have to do the experiments to determine that. And from those experiments, we can do like we've done in the past, create the formulas from the actual experimental results, knowing what we're doing, and say, oh, therefore this formula can be tuned using tuning parameters or whatever to accurately predict the anti-gravity field. That'll go along with the hardware we built, and then we'll have much more knowledge about it. But we have to get there first. We have to first understand and realize that magnetism is the road to anti-gravity.
Well, and that was part of my question, but at the same time, it was more of, do you personally think it's going to be an energy amount that is not obtainable at this point, or do you think it's probably something that we could actually produce?
Yeah, I think
Because we won't know, of course, until we measure it and figure out how much is necessary for whatever trips you're making or whatever project you're trying to do. But I just was curious if we even have a starting point where we could even create that field or have the capability of doing it.
I do think, because aliens have succeeded, and obviously whatever power generating device they're using is providing ample power for the ship, and it apparently is no bigger than maybe a basketball in size. The power plant that they're using, and maybe even smaller. I don't know, but they've succeeded, so I know it's possible. Because they don't have magical powers. This is not magic that they're doing. It's physics, it's science, it's real. We just got to determine how they're doing it. So I think that we can generate the power to do this. Certainly for experiments here on Earth, we could have access to all the power we need. The only problem is the superconducting wires. Do we have that technology, that room temperature? I suspect we do.
I think so. I mean,
Because
our fiber
we
optic
have it,
capabilities are pretty good.
we must have it. We must have succeeded because there are people that I know, that have seen UFOs up close and seen the markings on these UFOs, and it said USA Air Force experimental. So obviously, we have succeeded. We have figured out a way to generate the necessary power. How much it is, I don't know. Is it kilowatts, megawatts? I suspect it's probably megawatts. But
I was almost wondering if it was.
we're just not talking about it, because it's classified. Any
Yeah, I
kind
was
of
wondering
power
if we
generating device.
harnessed nuclear. I was wondering if we kind of harnessed nuclear to do it, or if it was, an actual like stored battery charge or something like that, or if it would have to be something greater.
I think earlier designs use nuclear because there's some UFO reports where people, where there was a UFO spotted and there was helicopters around it, and this UFO was emitting huge amounts of radiation. So at one point, I think we used, a very small nuclear power supply, which is not safe. You can't really effectively shield the people inside the thing are going to be killed within hours, from the radiation. So it's not really a practical way, but you can get a lot of power from, nuclear fission, heating up and driving, the motors that spin the magnets that make the electricity. I think there's some other way that's probably been patented and then suppressed probably by power companies, that's out there. The technology is being used. There's a lot of technologies that I feel that are being covered up, and the government knows about this stuff, and they're using all this stuff to build the spacecraft that they already have. What I want to do is make it so ordinary people can have access to it, build supercars, super ambulances, get to other parts of the globe in a matter of minutes, be able to go to Tahiti in 10 minutes from Florida. That's what would be cool and a great thing. It's very liberating and increase our freedom and our ability to travel anywhere we want on Earth in a matter of just a few minutes. It'd be a tremendous breakthrough for the world. But we have to get by this, the government covering up things and saying, "Oh, that's not possible. That's science fiction." A lot of physicists are saying, "That's not possible. That's science fiction. That's never going to be." Yeah, it's going to be. And so we need their help. We need them to kind of snap out of it, working on this stuff, because it can be real. It will be our future. Sooner or later, we're going to discover anti-gravity, and I hope to help do that by this book and by helping people do the experiment.
Well, and that's definitely one way we're going to help people with the propulsion side. But another thing I wanted to bring up, I know we're kind of jumping around a little bit, but can you tell me a little bit about Project Sunshade?
Yeah.
Because what was that?
I was giving thought for uses for anti-gravity technology. So I thought, well, anti-gravity drones could build things in outer space at a very, low cost. Whereas if we were going to build Project Sunshade, which basically is using blinders, a blinding system in outer space to block sunlight to cool down the Earth's temperature. And you can make these blinders so that they turn. So you allow 50% sun or 100 or 90 or 99 or whatever you need to do to cool things down a little bit. And this would be way too expensive if we use rockets. because to lift this stuff out there, just a few hundred pounds would cost millions of dollars every time we do it. And Project Sunshade requires at least 2 million square miles of space. We uh, have this shielding put up so that then we can send a radio signal to it and turn the blinders to whatever amount of blockage we want. I would imagine in the beginning we'd use 100% blockage. And if we wanted to make those sunshade things generate electricity, we could use solar cells as the blinders, and then somehow, maybe using microwaves or whatever, beam the power to Earth. So they would have a double advantage. We would create electricity with this technology, and you would cool down the Earth at the same time. Now,
that could also help with our big global warming problem.
Yeah, if you got 2 million square miles, we'll drop the Earth's temperature by probably 1 degree average temperature, which would put us back into the 1940s time frame for winters. So if you remember, you probably weren't alive, but I wasn't alive then, but I remember the 50s. We had cold winters up north, and even Florida would occasionally get a sprinkle of snow. And we had big cold snaps down here, which we do not have anymore.
Well, I'm in the Chicagoland. I still get my cold winters.
Yeah, you get really cold winters back the way it was in the early part of the 19th century or 20th century. And that would be great. Everybody should be happy. If we can hold off the warming problem doing this way, and it can be adjusted so that if it's too much, then we can turn on more of the light. And if we put these panels so they block light over the what they call Hurricane Alley in the Atlantic area and Caribbean, we control the hurricanes. We could basically kill them before they or limit their strength so they don't kill as many people and do as much damage. So we can, have double duty there if we put the sunshade in that area, control those storms, which always are coming off the African coast, coming across the Atlantic into the Caribbean. So that's where I would place the sunshade so that the shadow falls in these areas.
Okay. Well, so with this, I know it's just a theory you're putting together with the Project Sunshade. How far away from the Earth would it have to be between the Earth and the Sun? Would it be miles off of the Earth, or would it be closer to the Sun so that you didn't have to have it as large? It would because I'm thinking of when you hold your hand out perspective wise, you can cover up the Sun with just your hand. It just depends on the distance from your yourself and your hand.
I'm thinking you have to have some sort of geosynchronous orbit. So
okay,
at least 22,000 miles away from the Earth's surface. A little more, a little less, depending on what gives you more shade per unit squared. As you're closer to the sun, will it give you more shade or less? I'm thinking less. So you want to be kind of close to the Earth and get a bigger shadow by being closer. But I would say somewhere in the neighborhood of 22,000 miles up and in a geosynchronous orbit. So it's basically in the same spot blocking the sun all day long. So as the Earth spins, different areas getting the sunshade all day long. So even the African coast and part of the Atlantic and Caribbean is only going to get the benefit of the sunshade for 12 hours, but during the daylight time, which is where it's needed to be in order to kill the hurricanes.
Yeah.
So that's how I would situate it, and that would, again, make the world a safer place and more livable and less major problems. And eventually we could drop the temperature back to a more reasonable temperature. And every civilization is going to need to do this if they want to stay on the planet, because the sun is slowly burning hotter anyway.
Mm-hmm.
A minuscule amount increase in heat over the centuries, even. But it is a steady increase because the sun is running out of hydrogen. And when it switches to helium, it's going to burn hotter. And we're going to have to deal with it or get off the planet, which is another reason why we need this technology. We can live on this planet longer with more and more sunshade built. Uh, you know, tens of thousands of years from now, when the sun's heat is so much so that we need to do something, we'll already have it built and ready to go. And if we need to get off the planet because of some major catastrophe that's going on, we'll be able to do that. We'll be able to save the people from extinction, from large scale death by being somewhere else. If you want to get hit with a blow, the best thing to do is move out of the way, not let it hit you. So that's what we would have to do. We'd have to move to another planet. And we can't do that with rockets. We're going to have to go faster than the speed of light. So there's a lot of reasons why we need this technology. The future of humanity depends on this being done.
Oh yeah, and it sounds like if you want to stay on this planet, you almost have to accommodate. You got to make it work for yourself because I mean, I've always had this theory. We've been coming out of the Earth has been coming out of an ice age for a long time. I think at a natural state, the Earth probably doesn't have frozen ice on both ends. I think when it eventually gets to the state that it is cooling from, I eventually think it could just be solid water. It doesn't have to be. It doesn't necessarily have to be frozen. I think, but we're perpetually getting warmer as well as the sun heating up. So yeah, you're gonna have to do something to adjust for that.
Well, there's cycles in the sun too that make it burn a little bit hotter, a little colder over the decades, and that's in play as well.
Mm-hmm.
But eventually, the sun, and what I'm concerned about that physicists are not aware of at this time, but they're another one of my predictions that I'm very certain is going to be proven correct is that the sun has a solid neutronium core. That means that a considerable amount of the mass of the sun is in hydrogen. And
okay.
that's
So it
the
could burn up.
case. So yeah, we're going to run out of fuel a lot earlier than they're thinking. It just depends on how much of the core of the sun is made of solid neutronium. If it's 10%, that's a serious chunk of hydrogen that's not available to burn. And that could be a problem. Maybe only affect us by a few 100 million years. I don't know. I would guess that, maybe between 1 and 500 million years, less fuel than we think we have. Hopefully it's not more than that, but it's possible. So we need to determine and realize that all stars have neutronium cores, as well as planets like the Earth. I believe we have a small neutronium core rapidly spinning inside the Earth, and that's how it was formed, from a neutronium rapidly spinning sphere, which came from the Big Bang, which I spent 3 chapters of my book explaining. So it might be too much to get into here, but that is my cosmology theory, which all basically links together and makes sense. And planets and stars have to have a strong gravitational force to draw the hydrogen in, which then is used to build all the other elements. You start with hydrogen, you move to helium, then carbon and silicon and gold and lead and all this stuff. All these elements, I believe, were made here on the Earth over the hundreds of millions of years before life showed up here. And sure enough, we do have all the elements. How did that happen? They didn't just fall out of the sky, which is, I guess, the current theory. I don't think so. I think they were made right here on planet Earth. And it's done through fusion, and you need, I don't know what that was, but that was interesting. We need fusion to do that, and the only thing that create the gravitational field strength strong enough to do that is a neutronium sphere, which has immense gravitational field surrounding it.
I wanted to also ask you, what is what? How would you define a stellar converter?
Oh, yeah, that's another idea I came up with to try to fix really, really big problem, which I don't know should be fixed, but I came up with the idea anyway. uh, for future humanity to deal with if they so are so inclined. Now, the stellar converter basically is a way to undo neutronium. See, neutrons have a strange habit. They they operate differently depending on their circumstance,
Hmm.
which I believe is proof of intelligent design. Because and physicists don't know why this happens, but if you isolate a neutron by itself in outer space, away from every other neutrons and protons, that neutron will decay in about 15 minutes to a proton and electron, which is hydrogen. And who needs hydrogen? Every new universe needs lots of hydrogen to build stars. So a convenient way to store hydrogen is store it in neutronium spheres, which come out when the Big Bang happens, according to my theory, along with huge amounts of neutron gas. Free floating isolated neutrons within 15 minutes converts into just what the universe needs, hydrogen, lots of it. And these spheres will draw in the clouds of gas and form an atmosphere around the neutronium spheres. And the next thing you know, you have stars. And an explainable way, a sensible way to explain how stars work and are created. Uh, the Earth and the smaller planets are probably just smaller neutronian spheres that are spinning. This is how Earth got its spin, how the sun has its spin. It's from that core, that rapidly spinning core that happened when the, the Big Bang happened and all of this neutronium and neutronium gas was released. So that's basically, so the stellar converter is a way to undo the neutronium. If you approach it using the stellar converter, basically you're using the cyclic bias drive technology to create an intense magnetic field. Then you draw in close to using a ring shaped device, like a straw, a cylinder shape, and you drop it down on the pole. And these straws are made of these concentric rings of magnetic coils. So you drop it down on the poles, but you don't want to be shooting a neutron beam out from the equator or something. Will be spraying all over the place. You do it at the poles, it basically just shoots out the top and the bottom. And if you're familiar with that idea, then you're thinking, well, hey, I remember quasars look like that.
Hmm.
They're shooting something out of the poles, and we made some measurements, and we were seeing that the light coming out of there is polarized, which means there's a huge magnetic field there. So who made that magnetic field? Is it naturally occurring somehow? Because these are black holes, and things usually don't go flying out of black holes, right?
No, not
And
you.
where's the only place on the sun that has these solar prominences that shoot out huge amounts of particles? They're in the dark spots. And what are those dark spots made of?
Hydrogen.
Well, yeah, there's hydrogen. The whole atmosphere is hydrogen, but there's an intense magnetic field in that area.
Okay.
And when that happens, all of a sudden, those particles can escape the intense gravity of the sun. More evidence that magnetic fields cancel gravity. We have to get on board with this. So what I'm saying is I'm using sunspot technology basically for releasing the solid neutroniums. Once you drop down and touch the gravitational field that's holding the neutrons in place is gone. So they can follow up the shaft of this neutron of this uh, magnetic uh, coiled system and shoot out the top and bottom of the neutron star, creating within 15 minutes huge amounts of hydrogen. So now, if you have a way to collect that, typically around, what I would do is I would shoot it around so that it goes around the star and gets captured again and forms an atmosphere and eventually a star. But if you do that, you're going to wipe out the stellar converter. Then it's going to heat up and destroy it. So most likely, this stuff is just shot out into space. And you can do the same thing with black holes, because according to my theory, black holes are made of neutronium as well. And you just drop the straws down at the poles of the black hole, and you bleed off the neutrons, the material that the black hole is made of, until it diminishes, and you can eventually reduce it to nothing, and then eliminate a black hole threat. And in our case, we have a doomsday that's coming right now. And it's about 4.5 billion years away, which is about the time the sun will run out of hydrogen anyway. But our galaxy and Andromeda and many, many other ones around us are all moving towards something. That something is called the Great Attractor. And it's a huge black hole, thousands of light years apart. And we're being drawn toward it. So the reason that the speed of light is slowing is really a countdown timer. The slower the speed of light gets, the closer we get to the black hole, because light slows down in a gravitational field. We know that for a surefire fact. And that would explain why we're getting measurements that are being ignored right now, that are saying that the speed of light is slowing down. It's slowing down because we're going at approximately 1.3 million miles an hour toward the Great Attractor. And when we get there, life will end on this planet, this solar system, and this galaxy. And so there's another reason. Either we get rid of that black hole using a stellar converter, or we get off this planet to a safer place. There's just a lot of reasons why we need the technology proposed in this.
So when you drop those stellar converters in, I mean, this is theoretical, but if you were to drop one of those into a black hole, does it bring back the matter that was gone, or is it what's around the secretion disk, or where is that matter coming from when you drop that in there that it spits back out?
It's coming from the black hole itself. There's great misunderstandings right now of what black holes are. They've gotten confused with the problems with the solutions that say that things are infinite density, infinite mass. There's nothing infinite about a black hole. The solutions that we have aren't quite right, so they fail and they give us confusing results. And then we misinterpret that. And then we come up with these strange ideas of what a black hole is. A black hole, simply, according to the theory of super relativity, is a very large neutronium star. And when you get to a certain size, light can't escape it anymore, and then you get the event horizon, and it turns to completely dark. I think even neutronium stars don't really shine any light, so they would, to me, look like a black hole as well. But that what's in there is just solid neutrons packed tightly together, and you can do that with neutrons because they have a neutral charge, so they don't have a repulsive force coming toward them. It's many orders of magnitude stronger than the gravity that the proton emits. So since God, whoever created the universe, God created the universe, he designed it very cleverly, and the neutron is used in this case to store the matter and the energy for creations of stars and planets. So it's stored very tightly, neatly compacted into neutronium. And if you want to make more matter and get that matter back, you can do that by releasing it from the neutronium sphere into a state where it's not compacted anymore as a neutron gas. And rapidly, within 15 minutes into hydrogen, and now you can got the good stuff. But I'm thinking thousands of years ahead here, thousands of years ahead. to solve a problem that we're not under any threat of right now. But someday, the Earth, if we don't do this, if we don't reload the sun with hydrogen, or which we could do with a stellar converter, and then it would be a big process. It would be a massive scale project to try to bring hydrogen from somewhere else and reload the sun so it doesn't turn into a red giant, so that we can continue living on Earth. I think that the most practical solution is we'll have to leave the planet. And the sun.
Let me pick your brain here for a minute, Mark. What do you think? Because I've always liked the theory that on the opposite end of a black hole is a white fountain, whether it's in this universe or another one. Do you think it's possible that that's what the Big Bang itself was, a convergence of black holes in another universe that eventually spat out matter somewhere else?
No, I don't think the white hole theory is real, will ever hold, will never be proven because we'll never really see a white hole. The Big Bang would be the closest thing to a white hole, but it's not really a black hole just spewing out something from another dimension or another galaxy or another universe. When the Big Bang happened, it happened because this, the thing that holds a black hole together is gravity. And if you disrupt that process, creating the gravitational field, in this case, in the neutron, if you disrupt this process by packing them so close that they no longer can do this pattern, what will happen is there'll be photons shooting out of here. The core of that black hole, the big cosmic egg that blew up, will heat up. And when the neutrons are packed so closely together that this thing is interfered with, which interferes with gravity. And once you do that, it weakens the black hole and heats up from inside, and kaboom, you get another birth of the universe. And when does that happen? It happens when all the matter and energy from this universe collapses back in, which is already in process right now. The black holes will eventually combine the super titans, which they've already spotted out in deep space, and they'll merge like the Great Attractor. The Great Attractor is actually falling toward an even bigger black hole. This is happening. Nobody can change this. Nobody can deny this. They can try, but it will be a lie because there's enough astronomers out there that plotted this. They got the data to back it up, and it's happening, and it's sensible. And there's nothing going to change that. And it's only a matter of us acknowledging the truth and trying to do it in what way we can. So no, there's no white holes, not according to the theory of super relativity. That's a nice, neat, kind of exciting thing that a lot of physicists have come up with, and it's never really been verified. When a black hole becomes a black hole, that's one stable object, and that thing will live like that for billions of years until a force interferes with it so that it can no longer hold together. And the only way that happens in our universe is when we get enough mass, enough merges of black holes that everything that there is here in this universe is back together in the state it was just before it blew up the last time. And they've said there's some sort of a microwave background energy wave out there that says that this whole universe, there was another universe before it, and it had blown up, and they found the shock wave moving through the universe, and so they're thinking there's more evidence that this is a cyclic universe that blows up, falls back together, blows up, falls back together. It's an eternal process. It's a beautiful thing, really. It's a comforting thing to me that even though this particular iteration of the universe will die, the overall process of a universe being born and reborn will continue on forever. So that's a beautiful thing.
Oh yeah, and then that also ties into supporting the Drake theory and the fact that hopefully there'll be other people that will notice this occurrence happening. Maybe it won't be our humanity, but maybe another intelligent species somewhere else will notice this or has noticed it in the past. It's an interesting thought.
And when we get to faster than light space travel, when we go to other planets, we're going to meet people, and the government can't really cover that up. If we're flying on a starship made by Boeing or somebody, a commercial airliner, and we go there and we meet people, how's the government going to manage all these people meeting? Oh, you can't talk about that. We want people to think there's nobody else in the universe. That's nonsense. That's old-timey thinking. That's ostrich thinking. Of course, the universe is filled with life. We need to engage that and make friends and learn things. And we're going to learn a lot from our brothers and sisters in the sky. There are a lot of, I am sure, very peaceful, compassionate, loving species out there. May not look like us, and some may look like us, but we need to get together and learn all we can from each other. And the only way to do that is to get off this planet in mass and, maybe colonize another planet or two with the permission of the people there. And we be somewhere else just in case this planet goes bad so we can perpetuate the human species until the end of this universal cycle.
Yeah. Well, Mark, I wanna really thank you for coming on today and sharing this information with my audience as well, because I really wanted to hear what this book entailed, and it sounds like there's a lot more that we probably won't even get to today. We're about an hour and a half in. Is there somewhere you'd like to let people know where they can find a copy of this book, so that if
it's at www.super-relativity.com, super-relativity.com. And on the very front page, there's some big button links that you can go to Amazon and get it, or you can get a signed version from me as long as I'm able to do that. As long as I have time right now, I still have time. And so two places you can get it. Amazon, you can get a Kindle, or you can get the paperback, or you can order a paperback from me and I'll sign it and read it. Signed copy, which I think is going to be a really good investment. I have a very strong feeling that many, if not all, of my predictions are going to be confirmed in my lifetime. It's to make this book a really good commodity, especially when it's signed. It's like a once in a
say that address for me one more time. I wanna put it across the screen for us. You said it's Super Relativity, but where's the dash at?
www.super-relativity.com.
Okay. I just wanted to save that on here so everybody could see it as well.
There you go. Oh, forgot the .com.
Oh, forgot the dot. Yeah, sorry about that. But yes, hopefully everybody will be able to see that and connect. And that's where you'll be able to find his book. Yeah, Mark, we're going to have you on again soon. If you get some more free time, then we will set something up again here soon.
Yeah, it's a 500-page book, so I have a lot of really good ideas in there and things that can help the world get better. And I hope we can realize some of these things in my lifetime, so I can see that and have a comforting feeling that I did my part.
Yeah, exactly. And it sounds like you're trying hard to come up with solutions to help some of the world's problems, whether it's travel, whether it's global warming, whether it's weather. It sounds like you actually do have some solutions to some of the issues we're dealing with.
Yeah,
or at least you're brainstorming at them and putting together ideas, and we don't really seem to see that done most of the time these days.
Well, it's more people talking people out of doing things and talking people into doing things. That's what it comes to.
You can't just throw money at a problem and expect it to go away.
Well, well, that's just seems to be the only solution for everything. It's not really a solution. It's more of a cover up. It's more of a band-aid, which only allows the wound to fester and enlarge. So we have to do things with a mindful manner so that we actually fix the root cause of problems and not just cover things up. Make things easier by throwing money at
All right. Well, we'll end it with that. And thank you again, Mark. And I'm going to go ahead and sign us off. Thanks, everybody, for tuning in.